Hello my dear students. So today's topic is that is a dye laser. It is also called a organic laser or a liquid laser. The name is upon the active medium used. The active medium in this is a liquid, so that's why it's also called a liquid medium lasers. Clear? And we know that there are three components in a laser. What are that three components? One is a active medium, other is a resonant cavity, and third one is a pumping. So in this laser, the active medium is a dye, organic dye. The organic dye which we used here is polymethane dye, scintillator dye, and rhodamine 6D dye. Okay? These dyes dissolved in a liquid, that is a liquid that we can use water, methyl alcohol, benzene, etc. Clear? So this is about the active medium. Active centers are the organic dyes and the host medium, that is a liquid solvent. Okay? Then resonant cavity, that is always formed by the mirrors. So there are two mirrors, M1 and M2. This is a construction of this dye laser. So this is mirror M1 and this is mirror M2. Clear? Here we obtain the laser output, and this mirror M1 is replaced by a grating. I will explain it later that why we replace this mirror by a grating. So this is the symbol of a grating. Okay? Grating. So this is about the resonant cavity. Then is pumping, and dye is pumped by using a flash tank. So this is all about the construction and the components of the laser. So this is the diagram of a construction of dye laser. So this is a dye cavity, clear, with mirrors M1 and M2, and mirror M1 is replaced by grating, and we can rotate this grating like this or this. So this is grating like this. Okay? Grating is like this, then like this. This is a grating. Okay? M1 is replaced by grating. So we can rotate grating in this way, in this way. Clear? And these are the, we can dye in from this and dye out from this. This is called dye curvature. Okay? And laser output is obtained at this. Here, from here there is a pumping radiation. So this is the very simple diagram. Clear? But the structure of all we know that the structure of organic dye is complex. Clear? So in this way, active centers are the organic dye and host mediums are the liquid solvents. Okay? Then we can say that these type of lasers, they play an important role in atomic and molecular spectroscopy. Organic and molecular spectroscopy. Okay? Then about the laser beam output range. The laser beam output range is from 3000 angstrom, that is a visible region, to a 13,000 angstrom, that is an invisible or infrared region. Okay? And this range could be extended. This range could be extended, and it can go to far infrared using your optical harmonic frequency generation. Okay? So we can extend it. Clear? Then chemically speaking, that the structure of dye is quite complicated and bulky to look at. So because of suitable line width of the luminescence line dye, it is possible to tune continuously the wavelength of the laser line over a span of about 1000 angstrom. Or we can say that tuning of the you can say dye laser, that we can tune the dye laser, or we can extend the range means a wavelength. Okay? That I will explain at the last of this video. Okay? Then also the important thing in this, that in this type of laser, in this there is a dyes have a fast relaxation time. The relaxation time is very fast. Okay? Relaxation important. The relaxation time is very fast. So hence they can be subjected to rapid intensive pumping. Okay? For the tuning of the output laser radiation wavelength, it is necessary to use a special selection element. ठीक है. So it is for a laser radiation wavelength, it is necessary. So kindly pay attention on this line. So for the tuning of the output, or we can say laser radiation wavelength, it is necessary to use a spectral selection element. And what are spectral selection elements? That are the gratings. That are the gratings that we replace now this mirror by a grating. We can also use a dispersive prism, but here we use a diffraction grating. ठीक है जी. Then why we use this diffraction grating? Now question arises. So during this operation, during the operation of this dye laser, the large amount of heat energy, thermal energy that transferred to the dye solution. Here is the dye solution. Dye solution is inside the cavity. Okay, that creates a problem. What's the problem? The index of refraction, the index of refraction, that changes throughout the cavity. Okay, that results into a considerable cavity losses. What changes? The index of refraction, that changes. Okay, that due to that there is a cavity losses. So to avoid this problem, an effort is needed to keep the circulation of the dye solution in the tube or the dye cavity. So one mirror, that M1 of the usual laser setup, is replaced by this mirror, is replaced by a grating. ठीक है जी. And other mirror M2, that is partially transmitting, that gives the laser beam output. ठीक है जी. So this is called, we can change the wavelength which we want, we can obtain by using the grating, because grating can be rotated at any angle. ठीक है जी. So in order the radiation of a particular wavelength that can be reflected back along the cavity axis, the angle theta between the normal to the grating plane and the cavity axis. ठीक है जी. This angle theta, that is the angle between the normal to the grating plane and the cavity axis. These are the cavity axis. ठीक है. Must satisfy the Bragg diffraction condition. And what is the Bragg diffraction condition? That all of we know, 2d sin theta, that is equal to n lambda. Clear जी. Where what is theta? Theta is the grating space. ठीक है. Theta is the grating space. I write here. Theta is the grating space. And what is theta d. D is the grating space. And what is theta? That is the orientation of the grating. Orientation of the grating. And what is n? Order of reflection. Order of reflection. So d we know, n we know, theta we know. What about lambda? Lambda is the radiation wavelength. Lambda is the radiation wavelength. So for a given value of theta, or we can say the orientation of the grating, we will select only a single wavelength lambda. ठीक है. So in order to have a multiple lambda values one by one, so called the wavelength tuning. So what is wavelength tuning? To have multiple lambda values one by one, or this is so called the wavelength tuning. The grating is gradually rotated. The grating is gradually rotated. ठीक है जी. So as it allows only a particular lambda at a time in the laser output, so a device like a grating or a prism is rightly called the called the spectral selection element. What is it? Spectral selection element. So it helps in wavelength tuning. That I have told you that range could be extended to far infrared region using optical harmonic frequency generation or by using the grating. ठीक है जी. Thank you very much.